Okay, I guess I'm only starting about 3 minutes early, but that's okay. I'm basically going to start over again from chapter 2. I've already covered the first part of it, but this is one of those things that we've done a couple times, and it doesn't hurt to discuss multiple times. But chapter 2 is really, as I said, a long chapter. It covers the heart of programming. If you get that there, we started without you. I'm sorry. That there. So a lot of what you need to know for this course is in this chapter. So it's a very important chapter right there. So again, you should have already written a simple C program, or at least I gave you some time to write a simple C program. That there, the Hello World program, I think is that there, but that there. Use simple input and output statements. We haven't done any inputs yet. We'll be talking about that here today. We'll talk about all the various data types. Memory concepts we'll kind of talk about at there. We will spend some time on arithmetic operators, add, subtract, multiply, divide, modulus. Those are the primary ones we use. Sine, cosine, tangent, square root, those are functions contained in the MATLAB. So those are not operators, they're function calls. So we'll talk a little bit about the difference there. Well, one of the important things and what screws up a lot of programmers is the order in which we write our formulas. They call the precedence of arithmetic operators. In other words, multiplication happens before addition. Even though the way you write the formula, it looks like you do everything left to right, but in reality, computers will process an instruction a certain way, and if you don't write the instruction knowing that, you're liable to get the wrong results. And we can use parentheses. And then we'll be looking at some simple if, then, else structures, or if structures right there. Okay. Basically, I've already covered all of this here. C, and I talked about the fact facilitates a structured and disciplined approach, and I said that that's not exactly true. There are other languages that are more structured and are more object-oriented and allow us to do programming from a more systematic approach than C. C was originally developed as a language to write operating systems in. That there. It was not developed as a language to write computer desktop programs in. That there. And it was never intended as a language to be taught as a first-time programming language. That there. The simplest language that's been around for decades and decades for teaching programs for younger people and first-time programmers was a language called BASIC. BASIC is still around. I personally think that Visual Basic is probably the best first language to teach, but the UniKL structure is such that we only have one room for one programming class, so C is it. That there. And C is probably the most important programming language, in my opinion, for engineers because of the embedded nature that C can be used for. And even though everybody in this room is in electrical engineering, you think you're going to be working for TNB or another company is doing electrical engineering work. Well, some of you might find yourself doing other work later on. That's just the fact. I started off college as a student thinking that I was going to design radios for the military. Go to work for Magnavox as an RF engineer. Actually, I started off, I wanted to be a technician, repair radios. I did that for a short while for a state police post. That there probably is one of my shorter jobs because I found that they didn't have me repair radios, but I actually talk on the radio, and I hate talking to, as a police dispatcher is one of my least favorite jobs. That there, if you've ever watched, American TV shows. You see the person sits in the radio room and talks to the police cars and takes phone calls. That's what I did for about 6 months. That there, didn't like it at all. That there, I wanted to be out in the shop, taking the radios out of the cars and putting new ones in and finding, wiring shorts and things like that. And, that's what I want to do. But I ended up dispatching. But regardless, none of us know what we're going to do with our careers. And one of the things I've discovered in my, and I hate to say it, decades of being around this industry, I've first graduated from college and started working probably 35 plus years ago. I'm 60 years old now, 61 years old. So that tells you I've been around, a long time, is that almost nobody does what they intend to do at 20. When they're 40, they're doing something completely different. There are some exceptions out there. So as a result, what I was going to say, and my brain just took a sidestep, is that we've discovered, and I've done this both as a manager and as a young engineer, that it's easier to teach engineers how to program than to teach programmers how to do engineering. So you'll find a lot more programmers that used to be engineers that are writing technical software than you'll find programmers that are trying to figure out engineering problems. So you just have to keep that in mind that there. So that's why C is our language right there. Then of course MATLAB is also taught there. Okay, I'm not going to go through this. We've already talked about this program. You probably did it in either class before, only I think the printf statement just said hello world or something like that. But this is basically the first program. I talked about this at really great length, but I'll just kind of hit the highlights again. The first two lines there have the // that starts a comment. That there, anything after // should show up as green on the editor. Now, I can't remember what color. It might be a different color with Dev C, but with Visual Studio, it's green. That there, but it's a different color, and that simply says that those lines are that text is ignored by the compiler. The compiler doesn't look at it, doesn't care about it. That's there strictly for the use of the programmer in order to help you down the road, figure out what's wrong when your program doesn't work, figure out how you interface to it, helps other programmers, look at your code, use it. But these improve program readability and to document programming. And documenting program is important. I've talked about it before. But some companies will put all the software that everybody writes into a library, and every engineer or programmer in the company can go through that library and pick and choose subroutines or functions or programs and steal whatever they want from them. So there. And one of the key things about engineering as a whole is you don't necessarily reinvent everything whenever you do a new project. Up there, it's okay to borrow, steal, look at from other people. Now that's limited to copyright and patent laws and things like that. I mean, obviously, if you work for Samsung, you can't go to Apple's database or computer system if you got into it and steal all their designs and make the next iPhone 11, right? If they're to put the Samsung name. There's lawsuits that go on constantly between companies like from Samsung and Apple. I think I don't know, are they still suing each other? They're constantly suing each other for patent infringements. But obviously, if you two young ladies are working for the same company and you write a program to do X, Y, Z, and you've got to write a program that does something very similar, then take hers and start modify it and use it. That's perfectly legit. Now, as students, we tell you can't do that. You're supposed to do your own work. But as engineers, by all means, you typically will look at other people's work and borrow and steal and beg out there. As college professors, we beg, borrow, and steal from each other all the time. If you notice on the bottom of these slides, there's a little copyright notice. I didn't write these slides. I stole them from Pearson. Well, I didn't steal them. They put them online in a website for instructors to download and use at will. The only requirement is that I don't republish them with my name. I go ahead, I use them, but I can edit them and use them however I want. They put them in the public domain for that use. That's there. So same thing with programs. You want to write your code where other people can use it. Right there. That's just common sense. That there. If I'm Tanaga National, for example, and I'm paying this young lady so much money to write a program, and it's a wonderful program, and 5 other people in the company need to write similar programs, why make everyone start over again and pay them money to start from the beginning? You start off with a working program that there, and then you make modifications. One of the many jobs that I had when I was at Magnabox out there, I worked for a department called Test Equipment Design. We designed equipment that went on the production floor that would test circuit boards and test equipment in production during the production cycle. And we had oscilloscopes, function generators, multimeters, spectrum analyzers, all kinds of equipment out there on the floor, out there on each of our test stations, right there. Well, our software had to interface with all that test equipment. Well, I don't want to write the software to talk to a particular brand of oscilloscope every time I do a new project. I want to reuse the software that I used the last time. Or if I hadn't wrote a driver for that particular oscilloscope, I will call over to, hey Quadri, have you ever used, HP 2937? I just made up a number, oscilloscope in your project. Sure, can I have a copy of your code? And back then he'd hand me a floppy disk with a copy of the code on it. That's it. Nowadays he would just email it to me, right up there. But we would reuse this code all the time. That there. So that's why comments are important, right there. So I use this particular syntax a fair amount. That there, if I have a large comment, instead of putting / at the beginning of every line, I will put a / at the beginning of my comment, and I'll put a * at the end of the comment. Now I will do this actually a lot with troubleshooting code. I got a block of code that I know isn't working yet. It's not finished. I started it. I will comment it out to test other parts of the code. That there. And then I'll comment other parts of the code and test that part. So when I'm testing my code, I may comment out big blocks of code, and I'll use the *, or the */, because this will comment out 5,000 lines right there. Once it sees this one here, everything after that until it sees this one is a comment. So if I have 15 lines, I have 15 lines of comment. Now again, they refer to using the / because there's sort that there. So that there, because he talks about the fact that you can have errors and you put this one in and you forget the second one, so you comment out the entire rest of your code. But I will use this a lot of times for debugging code to block out certain parts of the code. I know something's not working, something's causing the crash, and I don't know what. Now, syntax errors are a little different, but logic errors, I know that there's something wrong with my code, but I have no idea where it's at, so I just periodically just block out parts of it sorry, this part's working. All right, let's put it back in. Let's block out this part out there, and you'll get into that there. So again, the anytime you see the number sign there, or the that's not asterisk, that I always call that the number sign. I don't know what the Malaysian term is for. I guess hashtag, I guess, is you know, with Twitter, that's become hashtag. Yeah, that there. But those are basically what they call preprocessor directives. Preprocessor means that before the compiler starts looking at your code and seeing whether or not it makes sense and whether it's got any errors in it, it will look for these preprocessors commands, directives. In this case, it goes and it gets a file from the C compiler directory called stdio.h, which stands for standard IO.h, is a header file. That there, we'll talk a little later about header files, but what a header is it tells the compiler that there's some functions out there that have certain forms. Right there. So if you use any functions that have standard input and output, you need to include the header files that define what those functions look like. Now, the functions themselves are not in the header file. The only thing that's in the header file is a list of the functions and what they look like. You know, they receive a value, they return a value, that they're, you know, that they just basically tell the compiler that these functions exist and they're coming. That the actual functions are actually contained in the library. Now, this class is an introductory class. We won't get into much detail on we won't learn how to create our own libraries and how to link external libraries to our code. But a library is a file or multiple files that contain all the information, all the actual functions that are called by C. So in the library, you'll find a function that calculates the cosine of a number. In the math.h file, you'll find a line that says what cosine is, and what it's going, and that it's there, but none of the code to calculate the cosine is there. So most of the time, the library functions are pretty well hidden and you can't look at them. That they're, you know, when you buy the compiler, they include the library with it, but they don't tell you what's in the library. That, you know, as far as how it does the actual calculations, and that can get you into trouble from time to time, because sometimes library functions don't work right. I told the story about the calculation that kept crashing on me, right there, and that was because there was an error in the library, right there. So, but you don't specify libraries at this point. You just specify what header files. Now you can write your own header files too. Right there. So lines begin, blah, 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 blah. This just says the same thing right there. Blank spaces are ignored. You can put as many blank spaces as you want. You can tab things as much as you want. You can put as many spaces in your lines as you want. C just ignores all that stuff right there. Obviously, as we start writing our programs, we're going to be formatting in a certain way to make it more readable or easier to follow. And that's especially true when we get into for loops and while loops and next statements or if statements and things like that. Okay. Again, we've gone through this, but I'm repeating it just because it's extremely important. Main is a function that we write right there. Every program must have a function called main right there. Main is the starting point of the program. That's there. And main can be very, very short. It can be very, very long. As a general rule, main is not a very long function, but it calls all the other functions in our program. When we look at structured programming, a common rule that was told to me by a pretty seasoned programmer, not a nice guy, I mean, I hate to say it, but he was a very, very good programmer, But his rule of thumb, and I've kind of kept it so, is that a given function or subroutine or subprogram should never be more than about 1 page of text. Right there. And I've written programs that have been, 400 or 500 pages long. I think some of them might have been twice that long because some of it I didn't write. I mean, we're talking multiple, but there's many function calls in there and many subprograms. But each individual function should do pretty much 1 or 2 things, and that's it, and then return the results back to its calling routine. So if they get to be much larger than a page, they become very difficult to debug and troubleshoot. And functions should be able to be troubleshooted and debugged on their own. It's kind of like if you're going to design an automobile. You don't start off with designing the automobile, the whole thing at one time. You design the engine. Well, and then you may not design the engine. You may design what the camshaft looks like. And then from the camshaft, you might design the piston rods. You might design the actual pistons. You might design what the rings look like going into the pistons, the cylinders, the block, the head. Every little piece of the engine is designed separately by different engineers. You break it up into smaller pieces. And that's what we do with functions. We break our code up into smaller functions right there. So main typically could be, I said a half page, a page long. It shouldn't be much longer than that. But that's our main routine. This just simply says, all right, now I'm really having, what am I that there? C programs must contain 1 or more functions, one of which must be main. I've already said we've already got that there. Every program, this just repeats. This here says that the word int to the left of main means that main returns an integer back to the calling routine. Main does not need to return anything. I could write the hello world and leave that int out. I can replace that int with the word void, which means nothing. That there. I can replace it with char. You can't necessarily return a string to an operating system, but you can. But it returns, in this particular case, int is main is returning an integer right there. So int receives nothing. So when we look at a function right here, whenever we look at a function, here's our function right here. Our function is going to have a list here of things that go into our function. And these come from the calling routine. Now, in this particular case, we're calling it from the command line, so we're passing it void. Later, we're going to pass it 2 numbers to multiply or add or whatever. And then at the end, here in this particular case, it's going to return back a single value. Now, functions, as a general rule, can only return back one thing. But we can change multiple things in them depending on how we pass the information to it. But we'll get into that later on that there. So again, the keyword int just simply means that main returns an integer to the calling routine, which happens to be DOS. When you ran this in dev C, you probably, I think the programming we started with was hello world, and we had a return 0, and you saw a little message at the end, program returned a 0. If you change that to return 5 or return 10 or whatever, they'll just tell you that it returned a 5 or 10. It doesn't do anything with the information. It ignores the information. Now, if you're in a batch programming mode where it's running multiple programs, quite often when you run a particular program in a batch mode, and a batch mode is a program that calls other programs. That their batch programming isn't as common now with Windows and real-time and embedded systems. But we used to do a lot of stuff with batch files right there. And if there was an error, you would return back whatever the error number was. And that would tell the batch program that that particular program didn't run properly. It crashed for whatever reason. It tried to open a file and the file was missing. It tried to do a calculation and the calculation was out, the value was out of range. It tried to combine two strings together and it was too long and overran the string length. I mean, something happened in the program and created an error. So generally, when we have main return something, we normally have a return a 0 if the program worked correctly. If it doesn't work correctly, we normally have a return an error number. But because batch programming is not something we do today, we're not going to do it in this class, so I'm not going to get into how we would write a batch program that there. Back in the dark days of desktop computers before Windows, when we ran DOS, there was versions of DOS from DOS 1.0 up to 6.0, and then DOS 7 was actually Windows. What was it? Windows 95 was the first version of Windows that was an actual operating system. Windows 3.1 or 3.0 or 2.0 were actually programmed shells that ran on top of DOS. DOS stood for desktop operating system, right there. We used to have a file on every hard drive called autoexec.bat. BAT stood for batch file, and every time you turn on the computer, it would run that program. Nowadays, you put all that stuff in the startup directory of Windows. So things that you want to run when Windows starts are in the startup directory right there. Windows takes care of it. Okay. So later we'll be writing functions, chapter 5. Okay. Right there. And I think I got there. So this kind of just goes through that program. I'm going to skip right through all this. I think I covered the escape sequences last time. This is a partial list of the escape sequences right there. So again, the backslash has special meaning out there. So printf is the name of a function right there. It stands for formatted print statement right there. So the first thing that is in a print statement is actually the format that there. In our example right here, we only have the format statement there. Normally we would have the format statement and then we would have after it any variables we wanted to print. We'll talk about that as we go through today, right there. So I talked about the opening and closing braces, that every block of code has to have a opening and closing brace. And again, going back to our program here. Oh, here it is, right here. This starts our program, this ends our program right there. Now later on we'll have other blocks of code. For example, we may have something that says for, and I'm not going to worry about what's inside that there. I may have a brace there and a brace here, And every line of code is executed so many times in this for loop. This is the start of a for loop, is what this is. For I equals 1 to 10. So it goes through and does this 10 times. So, but this starts the beginning of the for loop, and this starts the end of the for loop. It's the same braces as starts the end. So the braces denote any block of code right there. Right there. Okay. All right, here's where we start with the new stuff. Everything up to this point, I've spent half an hour reviewing the previous two lectures. But that's kind of like the old saying, tell people what you're going to tell them, tell it to them, then tell them what you told them. That there, repetition doesn't hurt. There, yeah. Okay, the linker is a program that occurs after we compile our program. There's a really about a four-step process right there. The first thing we do is we write our code. And you did that with the editor. Now, the editor is what allows you to type, and that there, it looks like a word processor. Back when I was a young whippersnapper, of 25 years old, 24 years old, a young programmer, I used to use a program called WordStar, which was a word processor, to write my code right there. We didn't have special code editors. We didn't have IDEs, which is integrated development environments that have the editor built into them right there. Visual Studio has a built-in editor. DevC has a built-in editor. If you work in a pure Unix and a Unix text mode, you may use a separate editor than the compiler right there. But typically we do the editing, then we do the compiling right there. The compiler goes through and looks for things in the code, make sure the code's formatted properly, make sure all the semicolons are in the right places, and we put all the quotes in there. But scanf and printf are not part of C. We teach them as part of C, and you would have a hard time writing any C code without using printf or scanf, but they're not part of the original language. Remember, the original language was designed to implement operating systems, in particular Unix, at Bell Laboratories. Ferdy and Richie are two guys that are famous in the computer world, and as engineers, there are a couple of young computer scientists / electrical engineers that work for Bell Laboratories, which was the phone company in the U.S. At one time, Bell Laboratories was the world's largest technological research organization in the world. And they designed the C language to develop Unix, which is the operating system that they use for telephone switches. Right there. Well, they didn't have at that time, Unix didn't have any monitors or any keyboards. They were operating telephone switches, so they didn't need scanf or printf, so they didn't include it in the language. It wasn't part of the language. But later, it's been added to the language. It's now included in the library. The job of the linker is to link your code with the library. So first you write your code, then you compile the code, then you link the code, and then finally you execute the code. So you've got multiple files that will show up on your drive. The first one is your .c file. That's your source code. Then you'll see a .obj file. That's the object file. That's the output of the compiler, .obj.
And then finally, you'll see a piece of code called .exe, and that's your executable code right there. Now we're writing code for the console environment or the DOS mode. We're not writing code for Windows. So we're not doing the fancy forms and GUIs. I might show you later how that's done, but we're just simply writing basic code that we run in console mode right there. So when the compiler compiles printf right there, it merely provides space in the object for a call to the library function. So the object file, the output of the compiler will not run because it doesn't have printf in it. It doesn't have scanf. It doesn't have sine. It doesn't have cosine. It doesn't have square root. It doesn't have whatever other functions you come up with, you can think of right there. All it has is a little place where it calls that function, and those functions are included in the library right there. So when we run the linker, it goes through and it finds it. Now, as it turns out, in our particular code right there, where is it? I know I've got it in here. All right, where is dev C? I ran it on this computer before. It should be right here in front of me. Right. How far? Right there. So this is the first one right here. And when I go here to execute, I've got compile right there, and that just compiles it right there. Now in this particular case, it tells that it puts it in the executable file right there. But I can add to project objects right there. File name, blah, 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 executable, directories I can include, output, various things I can put there. This one doesn't show me, but rebuild all right there. And if you go through and you look at these messages at the bottom, right here, you'll see that rebuilding the whole project right here, it creates what they call a makefile, which is the instructions right there, and it calls a program GCC, and it creates an intermediate right here called .o, that's the object file, and then it calls it again and it creates the exe. So it calls GCC twice, and GCC is actually the compiler that's running in the background. That's more detail than we want to get into. Since there's no final exams, don't forget everything I said about GCC because it's not important. Because what's important is when I come up here with the execute and I hit compile and run, it does everything for me. That there. It does everything in the background for me. It does the compiling, it does the linking, and it does the executing. It's all done automatically as part of what they call the integrated development environment. So it's all transparent. But back in the dark days when at least Dechtel Sr. wrote his first C book, there was no IDE, there was no shell. You actually wrote this code in an editor, then you compiled it, and then you linked it to the libraries manually. You had to know where the libraries were. And if you had multiple files, you would generate a make file that would tell it where all the files are. That's all done automatically now. So a lot of these slides here talk about the fact that the linker and the executables, that's all transparent in today's world. It's not necessarily transparent, though, in every situation. If I'm writing code for, say, a PIC microcontroller, or for an 8051 microcontroller, or for an ARM processor, I may be forced to do some of these steps manually because I'm not running a desktop operating system right there. So, right there. Okay, using multiple printfs, we can stick right there. So we can stick multiple printfs as much as we want right here. Here he's shown an example here. I'm not going to type this in there. But here we've got two printfs right there. Now one of the things to notice about this printf here is that there's no escape sequence at the end of this line. Without the escape sequence at the end of that line, it's going to continue printing on the same line at the next print at there. If we want to print this on two separate lines, then I have to put the /n at the end of each printf. That's it. So one printf can print several lines. So what we're saying here is that we've stuck in here 1, 2, 3 escape codes. So this is going to put print or welcome, new line, 2, new line, C:, and then new line. So again, I'm not going to run all these programs there, but the printf statement allows us to put multiple new line statements in there. And we can also do /t for tab and I think it's C for carriage return or something. I can't remember, but there's there's that list right there. Now here we're going to go through, and this is the program you're going to probably do tomorrow during the second half of the class. Right there is we're going to use the scanf. Now scanf scans the keyboard for input. Right there. So other languages use the word input, which makes more sense. Some languages use read, which makes more sense. C is a cryptic language, right there, and uses the word scan for scanning the keyboard, and F is for formatted input, right there. And we're going to we're going to scan in 2 integers right here. So here, what we've got here, and this is where, see, in this way, I'm not going to go. I don't go much beyond an hour in a normal lecture because this particular program has got lots and lots of new information on it right there. So first thing we've done here that's new is we've declared here 2 variables. These are places in memory that contain information. So integer 1 and integer 2 are the name of variables right there. And they're of type int. Int is a data type in C that contains real numbers, or not real numbers, but whole numbers. They go from like negative 32,000 something to plus 32,000 something right there. I think it depends on how the compiler and which processor you're using. But integer is a whole number. It can be positive or it can be negative right there. An integer does not have any decimal parts to it. You can't have the number 33.45. You can have 33, you can have 34, you in F33.4 right there. So, and we have two integers defined. Now, we can put them on the same line. I can have one line that says int I, J, K, semicolon, and I've just declared three integers I, J, and K right there. So here he does it on one declaration per line. I don't have a preference. I'm a lazy typist, so I tend to put things on the same line, but you can put them on different lines up there. And post-stroke, I'm even a lazier typist right there. So I would probably there. Now, there's kind of an unwritten rule, and it's not doesn't have to be followed, and it doesn't make any sense today, but it made sense way back 30 years ago, 20 years ago, that we start integers with I, J, K, L, M, and N. And the reason we did that was because Fortran required it. The old Watt 4 Fortran that was out in the 1970s, 1980s, require that integers start with I, J, K, L, and M. And that's because math departments always use I, J, K, and L, and M for summations and other things that use integers, right? You've seen you've seen statements like that, where it looks like this. I equals 0 to M minus 1. And then we have some formula. You've seen that in the math department, right? So they always use I and M and N for those things in the math department. And so Fortran stands for formula translation. So they carried over, and so they said that I through N was used for integers. So you'll find a lot of programmers that will still use I, J, K, M, I, J, K, L, and M and for integers. I still do. I mean, it's just habit right there. There's no reason to do it today, but it's just kind of tradition that there. So now C is unlike most languages in that C is case sensitive. So when I say case sensitive, the word integer, if it starts with a capital I, is not the same as the word integer with a lowercase I. So upper and lower case make a difference in C. Same thing with commands, printf. Many students would write printf like this. No, it won't work. It's got to be like that right there. It's got to be lowercase right there. So C is completely case sensitive. Right there. Except for the comments. Comments can be whatever you want. They're ignored. Pascal, Ada, Python, Fortran, Basic, they're not case sensitive. Other languages are not. Assembly language is not case sensitive. C is case sensitive. So that is just one of the problems that people get used to when they're working with other languages. They jump in with C, they don't realize that upper or lower case makes a difference with C, right there. Okay, now we've declared two variables. And these are spots in memory right there that right here, integer 1, integer 2, and these are just locations in memory that will hold numbers later on. Right there. This can hold the number 35, this can hold the number negative 128. It doesn't really matter, right there. But these are, so we declared two integers. Now, we do our printf right there. And let me erase that. Our printf, let me erase all this here. Right there. Our printf there says enter the first number with a /n. I don't always put a /n there. I may put a colon and then a space right there. It doesn't really matter. And that is a prompt. That's telling the user to enter the first number right there. Then here's where things get very tricky. And as I said, this particular slide has lots and lots of information on it. That there. And it says enter the first integer /n. That's just a prompt telling the user what to do. And then scanf is a function call. Now this function call is in the main library, and I included standard io.h, so the compiler knows that what scanf that they're. And scanf in this particular case is receiving two variables when I call the function. The first variable is one that's got a %sign and a D and a quote. That's a string. I'm passing it a string, and we're telling scanf that it's going to receive a decimal. That's what that means, and we'll go through the list of the scanfs later on in these slides. Then we're going to tell it that we want it to put whatever the user types into integer 1. And this is where C gets very confusing. And have I said more than once that C would not be my first choice as a programming language? Right there. I think I've said that multiple times. Right there. This has a little ampersand in front of it right there. And what that ampersand means is that we're passing the scanf not integer 1, but the address of integer 1. Otherwise, it can't put whatever we type into that location. So, for example, this young lady wants to buy a car from me, for example, and I want her to pay me for the car. I have to give her my bank account number, right, in order for her to transfer the funds to me, right there. So the bank account number is like the address of where my money is stored at the bank, right there. It doesn't do me any good to give her my balance in my bank account, because that doesn't do any good. What she needs to know is where to put the money. So in this particular case, scanf needs to know where to put the first number we type in. Where do we put that? And we're going to place that in integer 1. We're going to place it right here. So we have to not send it to 35. 35 is the contents of integer 1. We have to send it the address of integer 1. Where does this go in memory? That there. Other languages with input, we don't have to worry about this address, blah, 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 garbage. C, we have to. So C, when we use scanf, we have to put the ampersand in there. Later on, we'll see that we'll do that for any variable we want to change in a function. If we want to pass a variable by reference, or by value, we pass its value, and it can be used as a function, and we can't change it. If we pass its reference or its address, then we can change it in that function. In this particular case, we want to change the contents of integer 1, so we have to pass its address. So, scanf is a much more complicated command than printf. Now, printf we'll find later on here at the end of this program also gets a little messier too. So, but what we've got here is our scanf. First, we have to tell it in a format string what type of data we're going to receive. In this particular case, we're going to receive a decimal. And we denote that with %D. Right there. And then we're going to tell it where we want to put this decimal. We want to place it in integer 1. So in order to tell it to place it in integer 1, we have to pass the address of integer 1. You know, that there. Just like you call up Pizza Hut and you order a pizza, you have to tell it the address. Where do you want that pizza delivered? Right there. And Pizza Hut, for whatever reason, I finally discovered why, because their computer was stripping my street number, or my address off my address, you know, the house number. I had to put that in a comment on my web page that they're number 56, that they're, yeah, otherwise they couldn't deliver a pizza to me. I grew up with Pizza Hut. Pizza Hut's been around since I think Pizza Hut was formed in a company like 2 years before I was born. That tells you how old they are. They haven't been in Malaysia that long, but Pizza Hut's, I grew up with Pizza Hut, regardless. And they're not real pizza. Pizza Hut pizza, comparison to real pizza, sucks. That there, but it tastes like the American Pizza Hut, so I'll suffer through it. That there. Better than Domino's. Hopefully nobody does part-time delivery work for Domino's here. Picking on Domino's. That there. So we repeat this process for integer 2. So for every variable that we're going to input into our program here, we have to have a prompt for that variable and a scanf for that variable. So we prompt with the printf statement, and all the printf does is tell the user what they're going to, what to do. And then the scanf goes and reads the keyboard and gets the data for that there, and places it in the location. So we do this for both number 1 and number 2, integer 1 and integer 2. Now, he does something here I don't necessarily agree with. Here is he declares another variable here. Normally, I would declare all my variables here at the top of my program. That's where I like to put them. There's no reason to or not to put them at the top, other than maybe sometimes you're typing away in a large program and you realize that you need a temporary variable, so you declare it there on the spot instead of going back to the top and losing your place. So that usually, when I see something declared in the middle of a program, just tells me that was a sloppy designer right there. They didn't think the process through. But, I noticed when I go through the older Dectal books, and it's written by a father and son combination, that the newer books, and this one's about 1.5 years old, right there, that I see more of the son's influences, and I see more of these little lazy habits that pop up. That there, the father would never do that, but the son does it all the time. So I'm thinking that the father is kind of gone into the retirement mode and just kind of supervising, the son writing the books. But regardless, sum is now an integer, is also a variable. So we have another variable here called sum right there, right here. So it's been declared also as an integer right there. And then we say sum is equal to integer 1 plus integer 2. We just add those two numbers together right there. And then finally, the last thing we do is we use the printf. Now this printf is different than previous printfs right there, in that our format string is sum is, and then notice we have a %D here again, just like we did there. That means that we're going to, that's a placeholder for a decimal right there. And at the end of the line, we have a parentheses or a comma and sum. Now, also note that we don't have the ampersand on the sum because we're actually just printing the sum. We don't care about the address of it. The printf is not going to change. Is not going to change the sum. Sum is only changed at there. But we calculate the sum and we just simply add the two numbers, integer 1 plus integer 2. And when this works, right there, it's going to look like this. Enter your first integer, enter your second integer. The sum is right there. But that's our, a very simple program with input and output. And I'm going to give you time tomorrow to go through and do this particular one that there. So I'm going to continue on here, but keep in mind that tomorrow I'm going to go back and put this up on the screen, and I want you to enter it in that there. So again, this just simply goes through, and this is just slides that do the same thing I just did. I got a bad habit is I lecture according to the when I have the code in front of me, and then he puts the slides afterwards that covers the same thing that they're. Although he does state right here, he does show that he can put the sum there at the top. These are our three declarations right there. So these definitions explain that they're a type integer whole. He does show, as I just mentioned a few minutes ago, that we can combine all three of those on one line. We don't have to have three separate lines for integer 1, 2, and sum. We can do that as on one line right there. This is going to combine, but that would have made it difficult to describe the variables with the corresponding comments. Again, what he says there is that if you look at this code, he's got comments on each one of these variable declarations and what it means that there. And that's true, but C allows us like 32 characters to name any variable. So I think we could probably figure out what integer 1, integer 2, and sum mean without comments that there, or we could have one comment that just simply explains the three variables. But again, that goes back to how well documented the code needs to be, how nitpicky the person is, and that they're, I get in trouble with the admin staff here because I might write a final exam and they'll tell me that it needs to be an Arial type instead of Times New Roman and all that stuff, and I always come back with, who cares? The students aren't looking at what the font type is on a final exam when they're taking the final exam. They're only sweating whether or not they know the answers or not, right? That's there. So you don't care whether it's font size 12 or 10 as long as you can read the final exam. But somebody's job is to figure that out. And I suspect that many companies have somebody who's sitting there saying, it's got to be documented this way. And then you change companies up, it's got to be documented a different way. Or you change managers, and now everything has to be rechanged to a different format. So when we look at comments and that stuff, I don't care about that stuff because that changes so much from company to company, manager to manager. Some companies don't care how well you document. Some companies really get very nitpicky. Like I mentioned General Electric at one time. They were extremely nitpicky about documentation. Why? Because everything went into a database. It had to be documented a certain way. I worked for another company called Magnavox. Magnavox didn't care what we did. Of course, later on, Magnavox sold that part of the company off to somebody else, and Raytheon, when they took over that part of the company, they did care. So then all this code that everybody wrote that was sitting in the library, had to be pulled back out and redocumented to meet Raytheon's requirements. That there. So it all varies right there. So again, one of the things here is that when we name variables, there's a couple rules. One is do not stick an underscore in front of a variable name. Right there. You can put it in the middle of a variable name, but not at the beginning. And don't begin with a number as a rule. You can't label a variable 1, 2, 3 apple, for example. You can't use that name. You can use apple 1, 2, 3. That's okay. You also can't use underscore apple. Right there. The reason for the underscore is that everything in the library uses underscores. That's to prevent you from using variable names outside the library that are the same. So to distinguish internal library function or variable names, they use underscore in front. The same thing with function calls and everything. So the underscore is one of those reserved features of the C compiler or linker that you just don't use it for anything you write right there. So and of course remember C is case sensitive. I mentioned that earlier, right there. So common error using a capital that there. So he talks about the fact that a lot of people will use the capital. And this is a danger if you're using a word processor as your text editor. So if you're using, for example, Word to write your code, because you're so familiar with Word that you don't want to use that ugly little text editor that comes with Dev C, Word likes to capitalize things. That there. So that's just one of the, so you need to get that there. I don't recommend using text editors, word processors as text editors today. Back when I first started programming, WordStar had a programming mode. It was a really nice little text editor. WordStar since went out of business. They were replaced by another company that became the hot dog in the desktop computing world called WordPerfect, which I think WordPerfect's still around. And then of course Microsoft took over the world with Word and Office, so I think when everybody thinks about word processors, the only one that comes to anybody's mind is Word, right? Now there is another one called LibreOffice or OpenOffice. It's a shareware copycat of Office. That's free. I love LibreOffice, and I definitely like its price. I buy an academic version of Word that I pay $69 a year. I think includes 5 computers. So, my wife uses Word and Excel for everything, so it covers all the computers in the house. So I actually buy Office, and of course, you can find it from other sources, but I won't talk about the other sources here. But if you ever need a Word-like word processor or a Excel-like spreadsheet, look at OpenOffice. That's free, and they're actually very good. And they actually have fewer viruses and bugs than that. So choose meaningful variable names. That was something I mentioned a few minutes ago, that you had 32 characters roughly in a variable name. So don't use I, J, K, L, and M like we did back in Fortran. The old Fortran, you were limited to 2 characters. So you could use a variable name such as M1, I1, I2, IJ, but you couldn't have more than 2 characters with the old Fortran. That's all the space you had. Of course, keep in mind that I was also programming on punch cards, not a computer terminal either. I mean, we went to a teletype machine and that there. So, I mean, these are the dark old ages. But now you've got 32. So I can put a variable name such as GST underscore rate. And I can say that's equal to, what is it, 6, right? Right there. I can say GST rate is equal to, and I don't necessarily have to comment what, I don't, it doesn't, put in a comment there, GST rate, GST rate tells me that that's what the GST rate is, right there. So, and then, I can write the program, net sales are equal to blah, 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 GST is equal to, and you might put 0.0 in front of that there because it's 6% right there. So, but the GST rate, and usually something like GST rate is a constant that's throughout the code, but usually you declare it as a constant at the beginning of the code, so you're using 0.06 without the code, because who knows when the next government, if it changes, and I'm not saying it's going to change or change, might say the GST rate's not going to be 5%, or it might be 7%. I mean, tax rates change right there. So I lived in, I'm from the U.S., and the U.S. is terrible because every state has a different tax rate. So if you live in Indiana, the tax rate might be 7%. You live in Minnesota, it might be 6%. You live in California, it might be 7%, but then you may have a county tax, or you might have a township tax. So there's all kinds of different taxes, and each community can tax at different rates, and and add taxes up there. So and those are subject to change. So if you're writing programs, say for cash, for say point of sale terminals and that type of thing, where you're going to be dealing with something like tax rates, that is something that you have to keep in mind. One of the things that changes, for example, is income tax scales. I think when Najib released the new budget last year, he lowered the taxes for certain income scales right there. So if you had software that calculated an employee's paycheck, you would have to go through and you'd have to change the tax rate tables for that particular one there. So the new budget that was just introduced in the U.S. about 2-3 weeks ago redid a lot of the tax rates right there. And some people's taxes went up, some people's taxes went down, but they all changed. So all the payroll software programs out there had to go into their code, and they had to change where the brackets are, and and just kind of a side note, generally taxes are based on, and I'm just going to throw some numbers down, let's say above, we'll say 15K, we'll do monthly, so from 10K to 14.99K, it might be 28% or 20%. From 8K to 999.999K, it might be 18%. So these are different brackets that taxes are. So the more you earn, the more you pay taxes in a progressive tax system. And Malaysia has a progressive tax system. So it's just that when you're dealing with income taxes, it's not a single tax that you deal with. You have to, and these brackets change. Trump in his tax plan changed a lot of the brackets, and he changed the amounts in the brackets. So not only did the amounts change, but the brackets begin and ends had to change. So that was a fair amount of recomputing done there. So good programming of a simple variable should be a lowercase right there. If you begin with a capital letter or use all capital letters, that usually means something different. It's usually a constant. Now, something like GST rate would be a constant. that there, and we would declare, and we wouldn't, it's not a, GSD rate is not a simple variable. That's something that we use throughout our program, and it would not change typically in the execution of our code. It's that there. So, once we release a version of our software and we send it out to every Mammoc shop in KL, we don't let them change the GSD rate at the Mammoc shop, right? That's fixed into our code. But we have to be able to change it if the government happens to change the universal GSD rate. So multiple variable names, again, he's showing the idea of using the underscore and and again, this just goes through and just kind of goes through, explains everything I did. I think I'm probably at a good place to stop because everything in these slides have been covered. This is all dealing with that there. So I'm going to stop at this point. I'm going to start next hour, that's tomorrow, with you just entering this code and just seeing how it's going. And then I'm going to probably pick up, give you about half an hour to do that. Then I'll go through and pick up here with memory concepts in a little bit more detail. So let me start my recording. And